cracking. Patch. There we go. Alligator cracking in the wheel path. Let's say medium severity. I don't know, I suppose about 12 square feet. Transverse cracking, full lane, I'd say, in my opinion. Low severity. Probably the old freeze-thaw cycle at work here. That's what we get for living in Minnesota. And a patch. Low severity. 4x5, 20 square feet. 3 new temporary patches. 1 square foot each. Hi, I'm Jim Johnson. I'm a homeowner right around the corner here. I suppose you're wondering exactly what I'm doing here. Well, it's a hobby I got into. I was noticing that the streets are breaking up a lot, and I began to wonder what causes that. Maybe you had the same thought. Well, last year I heard that they were going to repair the streets in our area, and like a lot of other people, I wanted to know what they were going to do and why. So I went to a hearing, and our local engineer explained what they do to keep the roads in good condition. Now, he had some handouts and pamphlets. So one thing that caught my eye was this little manual on how to identify problems. They call it pavement distress. Well, I read it, and I decided I wanted to know more, and I kind of got into it. Even got myself a vest. Safety first, you know. Well, you know, this is a coincidence. I'm almost done here, and I'm going to go on over to the Public Works office and pick up some more information. You want to come along? It's interesting, really it is. Oh, come on. Hey, you might learn something. Well, there's hardly anyone around today. They're all out working. You know the old line. There's only 2 seasons in Minnesota, winter and road repair. Well, when they say that around here, they're not joking. On the way over, I was thinking we could just talk through this whole idea of road repair, or as the engineers call it, pavement rehabilitation. There's a pretty logical, reasonable process to the whole thing. The steps are outlined in this manual. The first thing we should talk about is causes. I learned that in order to know what to do about pavement breakup, you've got to understand what causes it in the first place. It makes sense, right? Then, we should consider the consequences of pavement breakup. I mean, how does it really affect you and me? Next, of course, you want to know how the people in our engineering offices make decisions about what to do. And last, what exactly are the alternatives? What procedures can be used to keep pavement in good condition? You know, there's really a lot more to this than you might have thought. And it can get pretty technical, more technical than I understand. But if we just take this one step at a time, I think you'll see that it's all pretty much based on common sense. Okay, so first, why does pavement break up? Well, as it turns out, there are 3 main reasons. The one we can't do much about is aging. As soon as new pavement is constructed, weather starts working away on it. Sun, rain, snow, temperature changes. Cracks running across the pavement lanes are one result. I found one this morning. This kind of cracking is caused by expansion and contraction. The pavement expands as the sun heats it up during the day, and then contracts as it cools during the night. After a lot of these daily cycles, the pavement actually pulls itself apart to form the crack. By the way, the street I was looking at has an asphalt surface, you know, blacktop. The majority of Minnesota's paved local roads are asphalt. The others have concrete surfaces. Of course, aging and weather are working against concrete, too. The results are shown in this other manual. Let's see here. This problem is caused by temperature cycles, too. The pieces of gravel in the concrete expand and contract, and that causes all these little cracks in the pavement. Well, there are lots of other ways that weather affects our pavements, and they're all bad. The manuals list dozens of them, but I'm not going to go into a long list now. The people in your public works department know them all. They use manuals just like these when they inspect the streets and roads in your area. Okay, so that's one reason why pavements break up: aging. Now, before I can explain the other two main reasons, I think you'll have to understand some basic ideas of how pavements are constructed. I learned that one of the most important goals in road building is to give the pavement enough strength to hold up under the weight of vehicles. So, what makes a pavement strong? Well, it has to be built strong from the bottom up. This is a model of asphalt pavement. What's down here at the bottom is the soil that was on the site before the pavement was constructed. Engineers call it the subgrade. It has to be strong enough to support the other layers and the vehicles above it. You see, some types of soil are stronger than others. And that's starting to get into the process engineers use in deciding how to rehabilitate a particular street or road. And I think we need to hold off on that topic for now. We'll come back to this business of soil types later, okay? Hey, trust me on this one. Now, this layer here is called the pavement base. It's usually a mixture of sand and gravel that's laid down and compacted by the road building crew. It provides some of the strength needed to support vehicles too. On top is the asphalt layer, the part we can see. It also provides some of the strength. The thicker it is, the more strength it has. So, all three layers contribute to pavement strength. And the stronger the pavement, the better it can resist the forces that are trying to break it up, which leads us exactly to the other two reasons why pavement breaks up. The second reason is us, you and me. Well, what I mean is our vehicles, especially the heavier ones, cause breakup by pressing down and overcoming the pavement strength. I found an example of that on the street too. Let's see here. This will show up right in the path of the wheels. You can see why they call it alligator cracking. Well, that's just one of the typical kinds of pavement breakup caused by vehicle loading. There are lots of others, but again, I'm not going to give you a long list. I think the important point here is that the amount of traffic and the weights of our vehicles are increasing all the time. A lot of our pavements are breaking up because they weren't really built to take the loads we're putting on them. So, as traffic grows and trucks get heavier, we're likely to see more alligator cracking and other problems caused by loading. All right. So aging and loading are two reasons why pavement breaks up. The third possible reason for breakup is that there may have been problems in the way the pavement was originally constructed. A lot of our streets and roads are pretty old. When they were built, the construction methods just weren't what they are today. And the quality of the materials, the asphalt and concrete, wasn't always the best. Making pavement materials is actually a pretty tricky business. The technology has improved a lot in the last couple of decades. So, three things that cause pavement to break up: aging, loading, and problems with construction or materials. Now, before talking about what can be done to keep roads in good condition, I think we need to stop a minute and ask, what are the consequences of pavement breakup? The answer is that bumpy, cracked pavement is inconvenient, and it costs each one of us money. Bumps make your hubcaps fly off and your tires blow out, and you got to get the steering on your car aligned all the time. It's noisy, so you can't hold a conversation inside the car. The coffee spills on the way to work. Bumps and loose material on the pavement mean the road isn't as safe as it should be. Then there's the cost of maintenance. The older a pavement is, the more expensive it is to maintain it. Yeah, I'll get back to that in a few minutes. Well, okay, so we have some ideas about what causes breakup and what the consequences are. That really leads us right into the process engineers use to decide how to keep pavement in good condition. Pavement engineering is a little like detective work. The engineers gather information, and from the information they find, and from experience, they make decisions about what should be done. One way they gather information is like what I was doing out on the street. They call it a pavement condition survey. Your public works department makes pavement condition surveys like that on a regular basis. They learn a lot just by looking. But they don't have to base their opinions just on what they can see on the surface. Most of the time, they also have records of how a pavement was built. Like this. It tells what type of soil was underneath, shows how thick the asphalt or concrete is, all that stuff, and a whole lot more. The engineers also keep records on all the maintenance that's been done over the years so they can see what works best. Now, they might have all their information on a computer. Here, the engineer gave me these printouts for the street I was looking at. Let's see, it's got a maintenance history, tells how many accidents have happened there, what underground utilities there are. There's a lot of info here. Two of the most important kinds of data the engineers gather are on what I was just talking about a couple of minutes ago, traffic and pavement strength. What the engineers want to know about traffic is how much can be expected on the particular street or road and how heavy the vehicles will be. To get that information, they might actually count the current traffic levels with one of those boxes you see next to the road with a rubber tube coming out of it. Or they can use formulas worked out by our State Department of Transportation that are based on decades of traffic counting. Then they add in predictions about future traffic based on planning for the area around the street or road. Gathering information on pavement strength is a little more complicated. The engineers can get some useful information by looking at one of these. It's called a core. It was taken right out of an asphalt pavement in just about the same way you remove an apple's core. The engineers want to see whether the asphalt is holding together or if it's falling apart. But they also want to know about conditions underneath the surface layer. So they drill down and get samples of the base and subgrade too to see what type of soil they have and what condition that soil is in. Remember, I said I'd get back to this. You see, you really can't trust me. Anyway, here's what they hope to find in the subgrade. Sand. They call it granular soil. It packs down good and strong so it can support the layers above and the cars and trucks driving on the road. But if the engineers drill down and find one of these kinds of soil, this one has a lot of fine silt in it, and this other one is mostly clay. Then they've got trouble. When these last two kinds of soils get wet, they hold on to the water, and that makes them weaker so they can't support the weight above. One thing they might find is that over time, clay or silt from the subgrade has moved up and gotten mixed in with the sand in the base layer, so the base isn't as strong as it was when it was laid down. Well, just looking at these materials is useful, but there's a more precise way to get information on pavement strength. Here's how it works. This machine does for pavement what my doctor does when he thumps my knee with that little rubber hammer. The operator runs the equipment with a computer in the van. He raises these weights and then drops them. That simulates the load of a passing vehicle. Now here's the most interesting part. These are sensors mounted underneath. They're like the sensors used for measuring earthquakes. The sensors measure the pavement's reaction to the load. What happens is the pavement actually bounces a little bit. Using data on the amount and type of bounce, the engineers can figure out the strength of the pavement and the strength of the soil underneath. They compare the results with previous tests to see if the pavement is staying healthy or if it's losing strength. That helps them decide whether they have good, sound materials that just need a little surface treatment, or if it's time to tear everything up and start over again. By the way, if you're wondering, the test is harmless to the pavement. That's one of its advantages over cutting out the cores. All right, so the engineers gather more data than you can shake a stick at. What do they do with it? What are the alternatives for pavement rehabilitation? Hey, glad you asked. There are dozens of individual rehabilitation techniques being used, and I'm not going to list them all. Instead, I think we should focus on the overall goal. The way my local engineer puts it is, do the right thing at the right time. He means you got to figure out how much a particular repair job will cost and balance that against how long it will last. And you have to do that for all of the reasonable alternatives and compare them with each other. We can take the street I was looking at as an example. I was talking it over with the engineer and I made some notes. Now, I'm going to leave out all the details about cost because this is just one example and costs vary from place to place and year to year. You have to treat every case individually, go through this whole process. Well, for that one street, the engineer said there are 5 rehabilitation alternatives. Let's see here. One thing you have to consider is they could do nothing. Now, of course, the initial cost of that is 0. But we've already talked about the consequences of pavement breakup, and I don't think anyone wants them. So we probably aren't going to go that route. Another possibility would be to just keep doing what we saw out there. Keep patching those potholes. That's pretty inexpensive, but pothole patches only last about a year if you're lucky. Now, that street is, let's see, 18 years old. Engineers figure an asphalt pavement should last 20 years with proper maintenance. So the pavement is getting out to the end of its life, and probably the number of potholes is just going to increase every year. Actually, in most cases, patching turns out to be one of the more expensive approaches over several years. So, what else could they do? Well, one thing they could do is called seal coating. It's real common. Here's how it works. First, they fill in the cracks and they patch the surface. But they do a more thorough job than if they were just filling potholes temporarily. They cut out an area around the pothole, then fill it in and roll it. Going through those steps prevents sagging and makes the seal coat last longer. After patching, they clean the surface. Next, they spray liquid asphalt on the surface. Then, they put down a layer of crushed rock. And last, they roll it. Now, obviously, seal coating costs more than just patching potholes, but a good seal coat lasts about 5 years. If you compare patching and seal coating on a cost per year basis, seal coating usually comes out cheaper, and we end up with a better driving surface. So, we should go with the seal coat, right? Hey, not so fast. There are still 2 more alternatives. One is, it's what's called an overlay. They would start just like with the seal coating, patching potholes and cracks. Then they put down a layer of asphalt, usually 1.5 inches to 4 inches thick. Now, an overlay costs more than a seal coat, but unlike a seal coat, an overlay will increase the strength of a pavement. Now, that might be necessary for a road where the traffic and loading are expected to increase. Plus, we get a very smooth riding surface. The crews aren't out there tying up traffic every year to do patching. And the best news is that an overlay can last for 10 years or more with correct maintenance. So, what's our last option here? Oh, right. This is the most extreme possibility, and it's something I mentioned before. They could tear up the old street and reconstruct it. The initial cost of that is the highest, as you'd guess. But a new pavement should stay in good condition for 20 years with proper maintenance. And reconstruction might be necessary. What you don't want to do is just put a new cover on top of old trouble. Another thing to consider is that if they were to reconstruct the street I was looking at, they'd add curbs and gutters to provide drainage and support the edge of the pavement. In rural areas, adding shoulders and ditches has the same purpose. Those things make the pavement last longer with less maintenance. So, which way do we go? Well, I guess you can see there's a lot to consider. As it turns out, they're planning to reconstruct the street I was looking at. It's pretty old, but that might not be right for the very next street. You have to treat each case individually. To come up with the right answer in any particular case, you have to look for the causes of breakup, consider the consequences, gather data from historical records and from testing, and consider all of the reasonable alternatives. The people in our public works departments do all of that, pretty much like I've been explaining it when they decide how to maintain our streets and roads. It's a complicated process that takes a lot of know-how. And hey, like I said, I'm leaving out all the technical stuff. The main point is they make supportable decisions. they can figure out how to do the right thing at the right time. If you'd like to know more about the decision-making process that's used where you live, talk to your local engineer. Hey, maybe I'll see you out doing a pavement condition survey someday.